Hello, my name is Augustine Egwebe, and today I'll be talking about the smart grid as an engineering concept. In concept of this presentation, I'll be talking about the grid itself, what has been the convention about the national grid, how electricity is generated, and I'll be looking at some new engineering concept called the smart grid. Why smart grid? Why do we have to go into smart grid? Why do engineers have to do so much research in this area? The diagram here is a normal paradigm of power generation, where you have your power coming from a central generation system through some transmission line and is supplied to the domestic consumer. And one main characteristic of this type of scheme is that the flow of electricity here is always unidirectional, in one direction. So the consumers or customers does not have any interaction with generation. All they do is to consume. There are so many problems that are attributed to such schemes. One of them is this technology has been on for more than 20 years. There's need for new IT systems to upgrade these systems. There's also need for consumers to be more involved in how electricity is generated, how it is marketed, how it is supplied. That way people can have more control over what they use, and if they don't want to use electricity, then they are happy to turn it off at will. Another problem as well is the issues with power quality. The people want good power supply in terms of voltage, in terms of frequency, in terms of harmonics, and all these factors put together leads to the need for us to reorganize the typical power systems network, and that gave birth to the scheme that's called distributed generation. And with distributed generation, the consumers or customers can somehow interact with the grid, either be in form of simple energy storage systems that can store electricity when demand is low, and then they can feed it back when demand is high. Or even the consumers, they can be involved in renewables like PV, like wind, small PV farms that not only bring money to them, but they are able to still feed it back to the grid. And like you can see from here, that way you now have a bidirectional flow of energy where there's not too much burden on the central generation, but generation is now distributed and is now closer to the consumers. So rather than generating from a very high central consumer generation and then going to some substation and keep stepping it down, you can generate energy or electricity at the point where it is being used. So the concept of smart grid, therefore, is what? It's we using modern technology, modern engineering skills in making the electrical network more sustainable, more reliable, and most importantly, more efficient for both generation and both consumers. And this is a typical smart grid network where you now have one is a bidirectional flow of electricity, but at the same time, you now have renewables, interaction of renewables, whether you are consuming from a domestic level, you are consuming from an industrial level, you have somehow an interactive link with the grid itself. And it comes with various advantages, and one of them is that technology itself becomes a key factor. The energy generation, distribution, and transmission that goes with technology. It is distributed. The market itself, electricity becomes cheaper for everybody. And there are so many regulations that need to change for this to happen. There are so many technical issues that are still involved with the smart grid itself, and even the bidirectional flow of energy within the more rugged and archaic microgrid. And all these call for research, all these call for financial investment into the smart grid so that people can be more involved. And being involved is encouraging the use of technology within the homes, within the transmission level, and within the generation level. Thank you.